Welcome to our MIT808 project presentation. I'm Tom, I'm with Blessing, and today we work through clinical decision support dashboard for prostate cancer risk prediction on South African patients. We will cover 7 sections: problem statement, EDA, methodology, result, discussion, dashboard presentation, and the conclusion for this work.
So the problem statement of our project is we're looking at the prostate cancer and how it affects African men specifically. We know cancer is a problem worldwide, but then the African population is underrepresented. So in order to solve this problem, we decided to use machine learning by using clinical data and build a dashboard that's going to be supporting us in our decision making. In terms of the data that we're going to be using, we're going to be using the age, the PCA, which is the prostate specific antigen, TMB, the tumor mutational burden, the PGA, the percentage of genome altered, and other key factors such as the driver count. So these data sets or features are going to be used to build a predictive model in order to determine whether a patient has a high risk of getting prostate cancer or not. This is just a breakdown of the ICPU, which is the grouping or the risk of each patient. So we can see that we have about 4 and 5 being the high risk and 0, 1 to 3 being the low risk. And on the other side, we can see the age distribution of the South African population of the EDM. So I'll hand over to...
So we train a random forest. So this is our model, and our model takes as input 18 features that we saw earlier. Because also, as we saw that the class is imbalanced, we applied SMOT, which synthetically generates new sample for the minority classes by interpolating between existing ones. It's been done strictly inside the 5-fold cross-validation fold. And for the interpretability, we use the permutation importance. So we shuffle one feature at a time and measure how much the model degrades. And we also use the random forest feature importance, so we can track how often and how early each feature is used to split the trees. Then also a wireframe in Figma for the dashboard of each page to implement our result in a very easy interface for clinicians. So as we can see, the confusion matrix here, so we have some errors. So we have 8 false negative and 17 false positive. But clinically, missing a high-risk patient is much more dangerous than a false alarm. So the primary metric is recall. We have a recall of 90%. So our model successfully catches 9 out of 10 aggressive tumors. That is very well. And then we have also here the random forest feature importance. So we can see that the prostate-specific antigen is very discriminative in the model. And then it's followed by the GMS, TMB, tumor cellularity, that also features that are very important in the model.
So for the discussion, so we do acknowledge that our model is not 100%. So for example, we have about 123 patients, which makes the data set quite small. So it affects our prediction. So meaning, and another setback that we have is that the class imbalance. So most of the patients in the data do not show any signs of having any prostate cancer. We only have a smaller minority class that affects our prediction. Then another thing that we're having is the ICPU, or the risk grouping. Since we made it binary, sort of affects our data. So ideally in future, like have more than 2 classes, so we can have a multi-class classification problem rather than just having a binary issue. So this is an overview of the entire dashboard of the model and our results. So the dashboard has three layers. We have the overview and the notebook, which shows the model and the individual patient. So on the page, we can see the EDA, or the most important features that were used to build the model. It's all the data together, but only the most important features that we use to build the actual model. And we can see the median age and other summary statistics. On the notebook, we can see the model results, the precision, and the other metrics that we use to see how well the model performs overall, and what actually made us to actually trust the results. So this is the analysis we did and the model that we built, and we can change certain parameters, the sensitivity of the model, and we can actually retrain the model with the changed parameters.
Then we have the individual patient explorer, so we can choose the right patient that we want to have. So we can edit the features that we have to update that. We can also manage the cohort. So we can remove the patient, or we can add a new patient. So we can add test and it will add that to the model also. So here we have the classification. So here we can see that it has been predicted high risk and it's high risk, so that's good. And then we have the raw patient record. Here we can see how the patient is compared to the median cohort. So the dashboard is quite promising and it's interpretable. So the future work will be to expand the cohort to improve the minority class, as we say, but also adding explainability at the patient level. We would like to thank Dr. Mfo Mokatlet and Prof. Vanessa Ives for their guidance on the access of for the datasets.